أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Now this is the most generalized form of solution. So what is, I am going to read it, and I am trying in this video to show the words as well while reading, or the sentence, or the proof itself. Division of a number eta into four parts in a four-term ratio Ka4. This is Ka, a Gothic letter, Ka4, that is equal to alpha 1 is to alpha 2 is to alpha 3 is to alpha 4, where eta belongs to real number, eta is greater than 0, alpha I belongs to rational number, alpha I is greater than 0, and 1 is less than I less than 4, where 1 belongs to natural number. So this is the whole situation. Note, alpha 1, alpha 2, alpha 3, alpha 4 may be written as Ka I is equal to 1 to 4 I alpha I. So this is actually, if this is written, this only means that this is the ratio, four-term ratio. Now I am going to show you more clearly. That is the proof. Now I am going to read the proof. Let epsilon is equal to alpha 1 plus alpha 2 plus alpha 3 plus alpha 4, and this is the summation I is equal to 1 4 alpha I, and that is the first thing. Now multiplying the equation 1 by eta. Well, eta is a real number, positive real number, greater than 0. Eta into epsilon, and this is the equation, and this is the right hand side of the equation. Now you can see this is eta bracket, small bracket begins, alpha 1 plus alpha 2 plus alpha 3 plus alpha 4, small bracket close, is equal to eta sigma I is equal to 1 to 4 alpha I. This is sigma. If I have pronounced this incorrectly earlier, I will make an apology. So this implies eta is equal to eta by epsilon, small bracket begins, alpha 1 plus alpha 2 plus alpha 3 plus alpha 4, small bracket close, and that is equal to eta by sigma, eta by epsilon sigma I is equal to 1 to 4 alpha I. That is question number 3. You may read it. Now we again come, eta is equal to, using the distributive property. I have used, not written it, but it is a distributive property. I think I may write it there. So this is the distributive property. I write it distributive property. Okay, applying there. So that is, it becomes eta is equal to eta alpha 1 by epsilon plus eta alpha 2 by epsilon, eta into alpha 3 by epsilon, eta alpha 4 upon epsilon, and that is equal to sigma I is equal to 1 to n eta by epsilon, and r is alpha 4, where epsilon is greater than 0, since the sum of any finite positive real number, I mean greater than 0, is positive, that is greater than 0. I have taken the word positive, greater than, in the meaning greater than 0. Please note it. Now B, this is a Gothic letter, B is equal to eta alpha I upon epsilon for all I. 1 is to I is to 1 less than or equal to I and less than equal to 4, and that I belongs to natural number. I have not written it, but I have written it there, so I may write it. It belongs to natural number. Now putting in 4 from 5. So eta is equal to b1 plus b2 plus b3 plus b4 is equal to sigma I is equal to 1 to 4 b4, and that is proved. This is the generalized. This can be generalized as the following. Now, second page, and what I'm going to say: division of a number eta into n parts in an n-term ratio, and that is ka n. This is the Gothic letter ka. Ka n is equal to alpha 1 plus alpha 2 and so on till alpha n minus 1 into alpha n, with the condition then that can be summarized as this. That is ka k a ka. This is the sound of ka. I is equal to 1 to n alpha I, where eta belongs to r and eta is greater than 0, and alpha I belongs to r. We have taken it and we have generalized it, and alpha I is greater than 0, and I is equal to 1. Is I is less than 1 or equal to 1, and equal to or I is greater than or equal to 1, and I is less than or equal to n, where n is a natural number. Now we can write it as follows. These are the notes. So I is equal to 1 ka n, and that is n from 1 to n. Then how many terms are there? There are n alphas, and each one is strictly greater than 0 and may be a real number. So this is 0, and now the basic condition we are using: 0 is less than summation of I is equal to 1 to n alpha I, and that is less than infinity, that is positive infinity. Now if nu is a positive real scalar, then multiplying each term of an n term ratio does not change the ratio. These are called equivalent ratios. So I will show you that these are the equivalent ratios, and people think that when you replace this ratio by this ratio you have changed something. No, these are the equivalent ratios, and if they are equivalent ratios then nothing is changed. It does only appear that it is changing, but it is not changed. So let I is equal to 1 to n ka n is equal to alpha 1 is to alpha 2 and so on to is to alpha n minus 1 into alpha n. Now I is equal to 1 I is equal to 1 to n ka prime, and that is equal to we have supposed nu alpha 1 is to nu alpha 2 and so on till nu alpha n minus 1 and nu alpha n. So these are essentially the same ratios, and we can say that they are equivalent ratios. So you may see that these are. Now fifth thing, that the only condition that is required is the sum of all ratios must be greater than 0 and less than infinity. There is no condition that they may be equal to any number greater than 0 but less than infinity. There is no condition, for example 1 or 2 or 3 or 4. There is no such condition. Just one condition, that it may be greater than, it must be greater than 0 and must be less than positive infinity, and also they are all real. Now fifth thing you should note, that eta and n, it is a very important thing. Eta and n are two distinct letters. The former belongs to Greek alphabets and the latter belongs to Latin alphabet. So there are many people who confuse these two letters. So eta has a foot and slightly curved, but in writing, but n has no long foot. So eta has a long foot. So there are two different letters and their pronunciation is also different. And now we come to nu. Nu is a Greek alphabet, and it should not be confused by u or v used in extended Latin alphabets. Classical Latin does not consider v and u as distinct alphabets, but nu is not a classical Latin alphabet, it is a Greek alphabet. So all these things are now clear. Now I have informed you and I have showed you that number can be divided or split into n parts according to n-term ratio, such that each term of the ratio is greater than 0 and a real number, and such a solution is possible. So we can say that the Qur'anic ratios are possible and mathematical solution exists for them. People think that when we calculate something is multiplied to these ratios or divide to these ratios, that this changes the ratios. No, the ratios are not changed, they are the same, and the result comes if we have chosen a problem according to Quranic ratios. The result is as according to the Quranic ratios. What is done in mathematics is a process, but the result is strictly according to the Quranic ratios. So we are not concerned that which method is adopted, either algebraic or arithmetical. But that's one thing is certain, that the apparent change in the ratios by multiplying or dividing a positive greater than 0 scalar or a number, a real number you may say, then nothing changes. The ratio remains the same. It is essentially the same ratio. So those who want to say that there is a mathematical error actually impose a condition from themselves, that is sum of the ratios must be equal to 1. But this is not algebra, this is not mathematics. You cannot impose the condition. The only condition is that the sum of ratios, all ratios in the 4th term or even in n terms, must be less than infinity and greater than 0. This is the only condition that is required. Hope that you will find it interesting. Thanks.